I welcome Ramanathan sir for this podcast. This is a podcast where I'm actually trying to get to know like what was that industry hustle that we need to put in. I'm a student, I'm still a student, I'll be a student for the rest of my life. But the end of the day, I'm supposed to face what industry professionals face. I think he has saw a lot of problem statements, he has been in a lot of different roles and different companies and different problem statements altogether. So I'm here to get to know what was that process of understanding this industry through Ramanathan sir, because you get to know through the fossils. Like these are the people who are in the industry for like 10 years, 15 years, 20 years, and they've experienced the way in which this industry has grown. Ramanathan sir is one of the desired guests on this podcast because we met in a TFUG Bengaluru meetup, and later on I asked him for the podcast and we didn't get a chance to do it because he was busy with the other things. So I think this is a chance now so we can get to know what's behind the next Ramanathan. We can get to know what's behind the making of the next prodigy or as the next legend in terms of the AI. I think I'm very humbled and I'm very thankful that he gave me a slot now. And thank you so much, sir. Thank you so much for giving me a slot.
Thank you, Vishwa. I'm really nice. It was nice to hear about me, the way you have put it across. Yeah, I am waiting to hear from myself, the person you are speaking about. So thanks very much for giving me this opportunity to discuss with you and community and whatnot. We'll go ahead. Let's start.
Sure. Let's just start with this question of like, when we are this children, we actually lose that adrenal rush of being that billionaire, millionaire, and things like that. And we pave our mindset in such a way that we want to be that next new package of energy and the source of knowledge that we really want to be for the world. Like we desire to be the best teacher. I want to know best in the TensorFlow and things like that. So I just want to know, like, how was your childhood? Like, how did you start your journey as a student and also the 20 and the 25-year-ish Ramanathan sir?
Okay. So I was a very average student. Okay. So I was a very average student in science and maths, and luckily I had some good maths teachers. So maths alone I did somewhat better, and I did commerce and maths. That was my combination in my high school. Post commerce and maths in high school, the choice was either do BCom or BSc maths, because BSc computer science and all those disciplines were reserved for science students. So either choose a commerce, or because I did maths, BSc maths was an option. And there was another option, BSc statistics. And those days I'm talking about, I joined BSc statistics in 1996. Nobody opted for statistics.
I was not born during that time.
Okay. So I did get seats in all three courses, BSc maths, BCom, BSc statistics. And ended up in statistics. Statistics those days was more of a theoretical discipline. At least in India, outside India, there was applications. I always looked at it as an application. It was not, the training in Indian schooling system. The training is more on focused towards acing the exams and by hearting. That's how the system was. So it was more of theoretical. So I studied mean, median, mode, design of experiments, inferential statistics, all kind of things I studied. Everything was equations and very little application those days. So that's how I did. I was good quantitatively. So that was something supporting me. So I did my statistics as an undergraduation in St. Joseph's Trichy. Then when it comes to post-graduation, I did it in finance. That is here in Tumkur. SIT, I did post-graduation in finance. So 2 years in finance. The idea was to bring these two together, statistics and finance. And those were the days where computers were coming into India. This technology wave was happening. So I studied in NIIT for 2 years course. So bringing together the deadly combination of statistics, finance, and technology, that was the mindset those days. And 9/11 happened. I hope many of you know what 9/11 is. And the recession started hitting. So I completed my post graduation in 9/11. I came to Bangalore. Bangalore was so nice to me. I ended up in a call center job, which most of us ended up in a call center job. I should put it. That was the opening that time. There was nothing called statistical modeling or analytics. The there was databases. Definitely, databases and spreadsheets were popular. But market research firms alone was doing some design of experiments and analysis. I did not find a place in any of those, so-called market research firms or top tier market research firms. I didn't have any contacts in small ones though. So I joined a call center. That's how I ended up in Bangalore in a call center, sitting around and working on it for 2 years, customer support, whatever. It was not directly a call center, somewhat vendor support, we call it, because I was part of a mortgage banking. So these brokers have to visit the places and we have to help them get to those days GPS was also not there, right? It was more of whether address is there, is the address correct? It was more of document verification and supporting the vendors. uh, that's how I spent my first 2 years. And you can imagine, after completing computer science engineering for 5 years, somebody sitting in a call center for 2 years is, I didn't do engineering, I did do math all, but yeah, that's how I was feeling. Then, then that's when my hard work started, or I wouldn't say hard work, my hard times. I had to go through a lot of things to be where I am. So contacts at every time came to my help. In those 2 years, I established contacts with few people, and one of the friend I still remember. His name was Badrinath. He was much senior person. I was a fresher out of college, but both of us were doing the same work. But he was doing uh, for a short period of time. So in that short period of time, I established some rapport with him, and he referred me to a market research company. This was a small time market research company which was doing market research for a bigger firm. So that is how I ended up in analytics. I always wanted to apply what I studied. So I was always on the lookout. I was sure I do not want to switch for another call center role or another back office role. Fine, I'll get my time, and I waited for that time. In the first 2 years in the contact center job, I got comfortable with my Excel skills, spreadsheet skills, basically, and database skills. So automation and whatever is necessary, I did acquire those skills. Then I ended up in a market research company.
Yeah,
So that was my college days. I would say that 2 years also was a college days.
yeah, I think probably because learning from math, I think a lot of mathematicians, statistics people, they have an edge over this ML and AI because it's all math at the end of the day. Like, I just want to ask you, like, how was that learning math was an edge to you in your journey?
Okay. Learning math alone is not going to give an edge to you. It's all you will see only equations in math. What is the unbiased estimator? What is the variance of an estimator? You have to know where to apply it. Today, many courses focus more on application. They don't touch upon math at all. They straight away go into linear regression, and then they talk about p-value. There is a lot of math behind it. Now it's mostly application oriented. Whatever colleges offer are all theoretical oriented. We have to strike a balance. How it happened for me is it happened over a period of time. I was learning all those statistics after 10 years of completion of the course. I hear all this. People talk about regression, people talk about classification. To me, regression is all about fitting a straight line. What is so much in it? Okay, there is p-value. I speak to people who are working on it. They also do somewhat basic work. No, the objective is to get the model going. They don't think about anything else. I started thinking from data perspective. For this data, is one model good, or will we need more than one model? Should it be linear, or should we think about non-linearity? Basically, it all started like this. We fitted a model, and the model did not behave good. Then a spark happened. Okay, we should build one model for men, another model for women to model the shopping behavior. Then the model turned out to be good. That is what was data science for me. It is not about regression or classification. Okay, this is the data for this data. Okay, what is that we should do? That is where I started. Then slowly things started exploding. Okay, you have gender as one group. Okay, we can build one model for men, one model for women. And within men, we have different age groups. Should we go about building 5 models for 5 different age groups? So I started looking at the problem from the data perspective than from the modeling perspective. That has been my bread and butter from the day one. Even today, we talk about fancy techniques, artificial intelligence or machine learning or deep learning. All that will matter only when you know what data to give as input. Basically, today neural networks handle this implicitly. It will build a model, one for men, one for women, but we wouldn't know that. That's what each and every node or each and every edge means. Why do we have so many nodes within a hidden layer? Because we expect so many different models. So neural network does what I was thinking when neural network was not that popular in India, at least. So I always approach the problem from the data side and focus on the solution. Not that I ignore the technique. Yeah, lots of techniques available. Techniques has its place, and there is math behind those techniques. Everybody should learn the math. That will give them a lot of intuition. Let's say you want to tweak it. How do you tweak it? Yes. For example, there is something called moment generating function in statistics. What are those moment generating function? How do I apply it? Today, you must have heard about that quadrant, Anscombe's quadrant.
No.
Anscombe's quadrant is one thing which says uh, any data, you can have two data which gives same mean. Does that mean both the data are same? No. Then two data can have different variance. Mean may be same, but two data can have different variance. Is that sufficient? Still we can end up with two different data with same mean and variance. Then there is something called skewness and kurtosis. So the idea is, if you have these these four numbers will be unique for each and every data set. This is what application is, right? So mean, variance, skewness and kurtosis. Within mean, you have multiple choices. When to apply mean, when to apply median, when to apply mode. All three mean averages. So you will have to keep thinking about it. Nobody is there to teach today. They will teach you, this is how you should calculate mean, this is how you should calculate median, this is how you should calculate mode. But when to apply what, not many people teach. So I also didn't have anybody to teach, but over a period of time, okay, this is the case I should be using mode as the figure. This is the case I should be using median as the figure. Similarly, you have multiple distributions, binomial distribution, Poisson distribution. Theory is one side, but from your side, you have to apply, okay, my use case needs Poisson distribution, or my use case is good with normal distribution. That took 10 years for me to build it. Trust me, it took me 10 years. I was in my resume, I say I have 10 years experience. That is when I was confident of answering questions. I was learning. Delivering in office is one thing. Most of the delivery happens around automation. Model building anyway is only 20% of the whole big piece. So data comes, we have to number crunch the data, we have to slice and dice the data. Then we know how many models to fit, and then we end up fitting. All that model has its own value. 80% of the time I spent on data. At that time, I continuously think about it. If you ask me one thing, the job of data scientist is to think. First job of the data scientist is to think. Anybody can code. The moment you have the roadmap in place, anybody can execute. But the expectation today is the person has to execute also. It is not just thinking, but the primary role is to think and execute. I was working from the days I was called an analyst. There was no term called analytics. In 2005 and all, I have not heard a term called analytics. Always analyst, senior analyst, data analyst. then evolved over a period of time. We called it analytics. The same job we do, but we call ourselves analytics. And later we did the same job, but we were called modelers, statistical modeling and all that. Later we did the same job. We are called machine learning engineers or data scientists. Today the fancy term is data scientist and machine learning engineering. It all I've been through all that. To give you a perspective, I don't know how many of you are aware of a database called FoxPro.
No.
FoxPro, many of you of this generation may not be aware of it. I started working in FoxPro. From the FoxPro days, learned everything. FoxPro, SQL Server, then SAS, then R, then Python, then Scala, Spark. Today it is again, outburst is happening. A lot of new things have come up. They call something serverless, serverless and function as a service, Kubernetes, containers. The domain just got bigger and bigger and bigger. The challenge is to keep up to that. The challenge is to keep up to that. When I was an analyst or data analytics, whatever we were calling, the expectation was to work on data and churn out valuable information, insights. But today, if you're calling yourself a data scientist, you should be a full stack developer too. They say, okay, yeah, you are the most capable person. So you tell me what infrastructure you need, or what should be the configuration of the infrastructure. You build it from end to end. You deploy the models. So today, the connotation for data scientists has broadened so much. 10 years ago in 2011 and all, it was you're good at data, you move to a leadership position. I was leading a team in 2011. I was good at only at data, SAS or R or Python. But in last 5 years, things have drastically changed. Deep learning has come into picture, and the machine learning engineers are expected to do everything, including development, full stack development, deploying the model, deciding what should be the infrastructure, GPUs and stuff. So expectations have risen. So everybody should keep up with it. I am trying my best to keep up with it.
Yeah, that's the best way because, in the olden days, I still remember, just before your podcast, I had a podcast with somebody called us Anuraj. He's also from Kerala. And he's the early adopters of the .NET and trust me, he started blogging about everything since 2006. And it was on a WordPress and now he has moved to another platform. No, it's great to hear something happening because we forget the fact that we are supposed to build something and we ponder upon everything like, hey, let's learn Impala, let's learn Scala, let's learn this, let's learn that. And like, what do you feel about like today's, like the flow of work? Like, is it like literally satisfying? Like we are just learning everything. Like, are we just getting that value out? What's your view on all these things that we are working on right now?
Yes. That is a question I was also pondering some time ago. I've been learning. Okay, there is a new technology that has come. Let me learn that also. Some point in time, I questioned to myself, what have I done with learning? We should basically invest our learning and get some returns. So with whatever I have learned so far, I can do so many things. We have to strike a balance. As a student, it's too early, but I would say at the end of 5 years or after 5 years of experience, everybody should put their learning into building something valuable. Today, the ecosystem is very vast. You have a lot of open source stuff. You get cloud spaces for free. Almost every cloud service provider gives $100 worth of credit. And you have without spending money on any of the licenses. Those days, for VB, we had to get a license from Microsoft. Now Python, R, and Scala, everything comes free. So you have to stop learning. You have to decide when to stop learning and start building something. And that is something is gaining more and more prominence because in industry now the recruitment happens based on your GitHub repositories. I get resumes. I see they give GitHub repository. I go check what kind of programs they have written, what kind of capable person the candidate is. now you will have to demonstrate value than acing an interview. Acing an interview, if we are strong on concepts, we can ace an interview. But demonstrating value, how would we demonstrate value? So from the student life, you should start building your profile, social profile or professional profile in this case, as we call it. You should have a GitHub repository. You should have something to show demo. That is going to increase the chances of getting a good job, in a good company. So some point you have to take a break from learning, apply everything you learn. Today you have everything. You want one excuse was there is no data with me. Before 2010, finding data was so difficult. Only companies can afford to have data and stores. But from 2011 onwards, there is a lot of new things came up. There's open courseware, those things came up, and then a lot of data got open source. You have a lot of data now, whether it is healthcare, whether it is retail, whether it is stock markets, whether it is company financials. Lot of data available is in the open market. You don't even have to pay for it. You get machines for free. You get data for free. Can you demonstrate value? Can you build something and keep it ready? Some point in time, it will come handy. It will be a very good exposure for yourself. Learning is important. There will be new things keep coming up. But it's not that you should end your life only by learning. Some point you have to take a break, take a step back, try implementing what you have learned. And I would even say you can learn by choice. There are hundreds of web frameworks, not that you have to know all of them, but you should know which framework which you are comfortable with, because every framework has its own uniqueness, and every language has its own uniqueness. You have to pick and choose. You cannot, okay, I completed learning Python, let me learn Scala. Now that I know Scala, let me learn Go. And now that I know Go, let me learn something else. I would say Python itself is sufficient enough to demonstrate value. There will be another language coming in next year. There may be, after Go, there may be another wave. After that, there may be another wave. Yes, you can keep learning, nothing wrong. At least keep updating yourself, upgrading yourself. But you have a basic skill set. The basic skill sets are what? One language, one database, how to handle a remote mission, basically some DevOps. How to spin a mission, what is Kubernetes, how do I deploy a server, website in a server, whatever it is. So you have the bare minimum requirements. With the bare minimum requirements, build something that demonstrates value. Maybe you end up with $1 million idea, and some company is interested in your idea, they may invest. That is the extreme it can go to. So always my advice for youngsters, even otherwise, a lot of people wanted to switch from other disciplines into machine learning and AI. Yeah, they can, provided they take this structured learning path. A lot of courses, either paid or free courses, are also available. Learning is important, that's for sure, but you should take a step back and see, have I learned enough to demonstrate value? That's all. The moment you have taken that step back and realized, yeah, I have enough to demonstrate value. And then you can spend time on learning or upgrading yourself. That can be secondary.
Yeah, you talked a very valid point, sir, because, today it's like everything you need to learn. Docker, you need to learn. Kubernetes, you need to learn. If some project people want some new framework or a new language, you can't keep learning some. You have to just do the process and learn with that process. Like, you just have to just get your hands dirty in the first time. Like, gone off those days where we were actually pondering upon, like, I have C language, I'm going to use that. C++, I'm going to use that. And it's all about the problem solving, right? I just wanted to ask you this one question. Like, today we have seen a lot of problem statements right now. Of course, you have seen a lot of problem statements through your data analytics journey, data analyst journey, and things like that. But I want to ask you this one question, like, what are some of the problems that are yet to be solved? I know that in those days, there were no programming languages that were so sturdy enough to give you some insights. Like what we have today, we have pandas. It can do everything. Matplotlib, it can do everything. But I want to know what was that process during those time, and also some canonical problems that are yet to be solved today.
Okay. Yet to be solved. There are problems, but we'll talk about. Okay. Let me think. Let me think a moment. One problem we solved some time ago, about 2007 days. Those days, big data and all was not uh, this popular. Servers and big data and stuff. We created our own framework to do map and reduce. We had, how I'll tell you, we worked on a data set which was 7,000 stores, and they have SKUs, store keeping units. We had to process so much data. One machine will run for 24 hours. So what we did is we intelligently divided the data. Let's say for 10 cities, in 10 machines will run the first process. That will throw an output, and we'll take the output and merge it in another program. That's how we did the parallelization. Today, that's what they call it, big data, all this. So that was an experience. What is not solved today? Infrastructure, we are kind of saturating. Infrastructure problems are more or less, we have everything what we need, at least in the problems I have been working on. You need a response in milliseconds. That's the ask. Yeah, spin up more servers, spin up more powerful servers, spin a server with higher RAM, more CPUs. You have everything. Now there is no limit. What they call horizontal scaling, vertical scaling. These were the challenges those days. We were not able to scale that quickly, and that was more expensive. Hosting a server on premises was more expensive. Now you don't have to host a server on premises. You can buy it in the cloud, and you can pay on piecemeal system. So infrastructure side, we have solved a lot of outstanding issues. Whereas from the problem statements, a lot of problem statements which is yet to be solved. In the AI space, a lot of healthcare related stuffs and all are happening. Healthcare problems, a lot of problems are yet to be solved, but there are regulations which is pulling it back. Otherwise, our people would go further ahead. Otherwise, every industry has some problem to be solved or the other. So problem solving will be there. Techniques are evolving. First biggest breakthrough was the machine learning from analytics. Those days in SAS we were doing it, and that was purely mathematical. You can solve some problems with max, not all the problems with max. So we wanted a generalized way of solving. That's where this machine learning came. So we don't assume any math. We give input. We give also the output. You tell me what the relationship is. I don't assume it is linear relationship. I don't assume it is non-linear relationship. How much of non-linearity is there, whether it is power 2, power 3 or exponential. So there is nothing about math. In the deep learning, there is nothing about math. It's only linear algebra. So we give the input and the output, and the algorithm will decide what weights should go where. So math was a bottleneck at some point in time. We came across the math, and now in deep learning, in last 5 years, all the bottlenecks have been one after another is being cleared. For example, in deep learning, when we wanted to do NLP, we did basic word embedding in NLP, and slowly then attention models came, transformers came, today BERT and all that. Today the innovation happens at a very rapid pace. It doesn't wait for 2 years, 3 years. Last year we had a problem, we'll go for a solution this year. So if you look at the NLP timeline, the papers which has come, first was deep learning, image processing. Then NLP, every year some new technique, transformers, attention models, BERT. Every new year we get a new paper coming out, which is because of the big tech that was possible. And there is also graphical networks now, graph neural networks they call it. And So we are solving at that rapid pace. It's all possible because we can scale up the infrastructure and there is a lot of funds to play with. Big tech is investing a lot of funds in this R&D. So today there is no dearth for funds, no dearth for infrastructure, no dearth for people, no dearth for problem. We have everything at our disposal. Problems exist. Is that something we cannot solve it? We'll have to wait and watch. If you say something, this is the problem, I cannot solve it, most likely you will end up with a paper next year.
Yeah, that's
Most
true.
likely you
That's
will end
true.
up with a paper next year. So that is the rapid pace I see things are going.
Yeah, like I think probably exam is giving an amazing set of papers every day, minimum, bare minimum 50 papers for sure. Any subject you take, astrophysics, computer science, machine learning, bare minimum papers, 50 for sure is being dropped into archive. And I'm so fascinated by the way in which the technology is moving. But like, I just want to ask you, like, you are from a very old times of like how the data science and the history of the data science was evolving. Like there
Mhm.
were perceptrons, there were things that were evolving, but they never applied it at the scale that we are applying. So I just wanted to ask you, like, you have worked in different problem statements and application development. What was the difference that you saw when you were deploying models? I don't think so that you deployed models in the early ages. I don't think so that any deployment happened, but it was only analysis.
No, no.
So how is
Deployment
it
is all
different?
a new term, for old school people. Deployment and all is very recent. After the machine learning models came, they want to integrate it with a larger system. This was not happening 10 years ago. Okay, this was the model. Who will ask for that model? Somebody who's going to take a decision. Okay, I am planning to increase the price by 10 rupees. Yeah, okay, somebody is going to make a decision. For that, what will be the impact? So we give the results of the model. Okay, if you increase it by 5 rupees, the demand is going to drop by so much. If you increase it by 10 rupees, demand is going to drop by so much. We look at the various facets where we use various techniques, and then we present our findings, and the decision maker will take the decision. That is the old school way of things. Now they want to integrate it with the larger scheme of things. That is where deployment and today there is a discipline called ML ops, machine learning operation, where continuous integration and continuous deployment, all this has come up in last 2 3 years. We did not even hear about it actually. I did not even hear about something called deployment 5 years ago. Today these were the job of what we used to call somebody as system engineers some time back. Today they are called DevOps. Today we have DevOps. Now we have ML ops, security ops. Things have evolved very quickly in last 5 years. So ML ops is where ML engineers and DevOps guys comes together. Now the line is again disappearing. There is no demarcation. This is the job of the data scientist. This is the job of the ML ops guy. This is the job of the DevOps guy. So the line is very quickly disappearing. A person is expected to do everything, at least have knowledge about everything, so that they can coordinate. Yes, deployment is all very new for us, but for you people, you should when you build a model, you should know how to deploy also. I'll tell you, my first model got deployed about 3 years ago. 3 years before, 4 years ago, and all 4 years before, I was not deploying any model. We build models and we share the outcomes as a data scientist at that level. Otherwise, for very fancy problems, PhDs were preferred. They were doing a different kind of a machine learning. They were all very well versed with neural networks in 2013-14 itself. They were ahead of us. So I deployed my first model in 2016-17, I would say. That is when I deployed my first model. Basically, we created a pickle, and then that's when I learned, okay, these are the big scheme of things. There is something called full stack. Okay, this is where the model is going to come. If you look at all this, your model will be only 2% of the bigger exercise. Yeah, there is a lot of engineering happening. There is a lot of development happening. There is a business problem outside the model. So your model is between 2 to 5% of all the big scheme of things. Today it is in demand. Yeah, it sounds fancy. 5-digit salary or 6-digit salary, whatever it is. At the end of the day, it is 2 to 5% of the big scheme of things, and that is becoming more and more important for a data scientist to know. It's no more you and your data. You have to know the context. You should understand, okay, this is the technology they are going to use it, so I have to give them a pickle file, or should I give them a TensorFlow model file? Those things are, everyone is expected to know.
Yeah, I just want to ask you this last question for you. I think not last question. I think I just want to ask as many questions as I want. You
Sure,
know,
sure.
earlier days the computers were not that advanced. Celeron processor was something which is more advanced. Like I just want to ask you, like, what was your first computer and your first code? Because you told a lot of things about the software and how the industry evolved and things like that. But I want to ask you, what is your first code and your first computer that you worked on?
Yeah, if I want to put it in perspective, I'll tell you. I got my laptop only in 2008. First 8 years of job, I never had a laptop. 2008 is when, not 2008, I had a laptop. Yes, 2008 is when I got a laptop that too was not from the company. I got my first laptop from the company only in 2011. Until then, it was all desktops. And I got a laptop because I had to remote log in into remote desktop. For that, I was using the laptop. That should give you an idea of what was the kind of systems that was available those days. It was not very high RAM. It was not very high CPU. Intel was the standard. If you can afford Intel, good. Otherwise, you end up in Celeron or AMD. Otherwise, nothing fancy about infrastructure those days. It was painful. We never had big data. That also we had to admit. Big retail companies alone have millions of customers and billions of transactions. Otherwise, the data generation did not happen the way it is happening today. Today, if you have a website, within a day, so many people visited. These are the parts they visited, and Google Analytics is something, gives you all the details. The scale at which the data gets generated today was not the scale. Those days, retail alone had some huge data. I was lucky to be part of the retail industry. So we have to be innovative to process the data. Whether should we process the whole data? For example, I worked for a big retail which had 1,700 stores. If I'm right, yeah, 1,700 stores. And if I write a query, it will take years to return. So what will I do is we index the tables. Today, the index is something called outdated, something like outdated. Those days we index the tables. So what I'll do is, okay, let me do region by region. Okay, for Karnataka stores, it will give me results. I'll use another machine to get the stores of Tamil Nadu. I'll get another machine to get the details about the stores of, let's say, Madhya Pradesh or Maharashtra. So we write 26 queries, run parallelly in 26 machines and get the result. So that's where the innovation has to happen. I think Google also had this big data problem. Hadoop was originally from Google, so they donated to Apache, if I'm right. So they had big data from the people who visit the websites, and the number of websites were growing exponentially. They had to index all the websites. So they came up with, they formalized this arrangement, having multiple machines, processing them in multiple machines. And they also were innovative or more applied in linear algebra. Their page rank algorithm is all on linear algebra. As a student, you can take a look at it. They would have used something called eigenvalues and eigenvectors to decide which pages are important, which pages are not important with respect to your search query. So apart from retail, websites started Google started experiencing such big data. They were innovative, and henceforth they became number one.
Yeah, you have seen the industry from that view because it was
Yeah.
nothing. It was nothing exactly. Exactly. I was in 2015 when the TensorFlow. I was in second PU when the TensorFlow came out for the market as an open source project, and it was still an internal project for Google, and they were still developing on it. And I think the wave in which the open source came in, I think it really shattered the industry. I think you said about Visual Basics was supposed to be licensed. They were supposed to buy the license for it, and they were supposed to use it. I think probably not before TensorFlow becoming open source. Visual Basics was also open source. I think so because
Yes.
yeah,
They
because
did
many of
open
them
source it later.
they did open sources later. I just want to ask you, like, what's the way in which you are seeing the frameworks now? Because I know that you have never seen a framework like Keras before. I know that you had never seen a framework like
It is,
TensorFlow before.
there is a reason for it. Those days, as we need, we develop. That's how it is. If we don't need, we don't develop. No, the invention is mother of all, or need is the mother of all inventions. I forgot what the term was. So we are evolving, and Google and big tech companies are investing in R&D. Today there are frameworks for everything you ask for it. Otherwise you have to code everything right from the scratch. For your question on frameworks, yeah, TensorFlow is a very stable framework. TensorFlow 2, TensorFlow original one, there were a lot of challenges for the developers, but TensorFlow 2, they have fixed it, and TensorFlow 2 has a lot more capabilities. And they are very stable also. That's my take. PyTorch is also coming up. Earlier, PyTorch was not preferred, but now both are equally treated. I hear models being deployed with the help of PyTorch as well as TensorFlow. We never had frameworks. We had only languages and packages. So for statistical analysis, there used to be something called SPSS by IBM and another package called Minitab. They are all, they are all spreadsheets basically with statistical tools. If you don't want those packages, you end up with SAS. SAS is very expensive. SAS those days were very expensive for license. And MATLAB. MATLAB was used in mostly in manufacturing sectors or math researchers. Otherwise, the data analysts use a lot of SAS. So we never had any frameworks those days. After R and Python came, then frameworks came. R and Python open sourced themselves. They allowed contributions from the community. You can contribute a package to R and Python and take credit for it. Let's say I build a package, I give it to, I contribute to community, I take credit. Wherever I go, I can say I have contributed to Python development community or whatever it is. That is when this frameworks and all started coming. And most of these frameworks were built for a purpose. And then this big techs open source it. For example, Hadoop is something built by Google, and then they open sourced it. And a lot of things. And most of the Apache technology you see are all built in companies and then got open sourced. So all this framework, all this explosion of frameworks happened after 2012, 13. Until then, it was a language and ourselves. We have to write something from scratch if you want it. Now, frameworks have made the life simpler. That's what I'm saying. You have everything right now. Infrastructure comes for free. Frameworks, languages, all that you need is okay. Take a problem statement, solve it.
Yeah. No, sir. I just want to ask you this one question because you have been learning for a very long time now. Of course, you have been saying that I've just been learning for a long time, and that's how my career blew. And I just wanted to ask you this one question, like how to learn something new beyond saying the reasons of like I'm in a professional world now, I can't learn new things. My job is so hectic, this and that. Like I just wanted to ask you like how to learn as a learner, leaving all the professional tag that we have and the things like that.
Yes. You should have a need to learn. You cannot pick a language to learn. You should have a problem and that problem should be solved using certain tools, learn the two necessary tools. I would say that would be more productive than learning one after the other. Let me learn 5 languages, 5 databases, I'll get a job. That is how people look at it. Okay, I have to get a job. Let me know more languages. Let me know more databases. Let me know more. Yeah, maybe for a job that may come handy. But I would say take a problem at hand, see what tools are available, choose one of the tools, learn, solve the problem, and that will be more productive learning. I did this mistake of learning one after the other, but I have decided, no, I'm not going to go and learn new things. If I have to know new things, I'll find somebody who knows that stuff and get that thing done. Otherwise, I am not sitting and learning anything new anymore. I'm working for a company, so mostly it is mentorship role for me. And I'm also inclined to build something which is worthwhile than whatever I've learned so far. I have to build something worthwhile. That is my personal goal, which I'm working on. Now everything is available. I pay now, I can afford also. So I spend about 5,000 rupees on all infrastructure pieces, be it serverless, be it Kubernetes. I have a database in cloud. I have some virtual machines in cloud. Every day night I spend 2 hours in using all this, and see what I can turn it on. At the end of the day, it's something you feel that achievement. Okay, I have achieved something, accomplishment. That's something is going to keep you going for the long run, for the learning. Otherwise you'll get frustrated. Oh, I've been learning. You'll be frustrated. So take a business problem or take a social problem. Social problem also is fine. There are a lot of hackathons happening. So there is no dearth for a problem today. There is no dearth for a problem. You want a problem statement, you get from any industry. I can give you 10 problem statements today. For that matter, anybody can give you 10 problem statements today. Any industry, any individual can give you 10 problems. Take that problem, see what data is available at you. Okay, you have this huge data, this kind of data. Okay, this data is not structured. How will I make it structured? Okay, can I process it structured in an unstructured manner itself? So you will question the moment you have a problem statement and data in your hand, a lot of questions will come. Go for answers, and you will eventually end up learning. It's not intended for learning. You don't start saying that I'm going to learn for the sake of job. You are going to start looking for solutions and then end up learning. That will be more productive learning. That is my input. But yeah, there are many, and your style of learning also is very different. Many people have their own style of learning. Some will be comfortable reading from a book and learning. Some will be comfortable listening to a video and learning. Somebody will be comfortable by coding and learning. So you have your own style. Whichever style it is, that is fine. But always look to solve problems. Today we use machine learning. Tomorrow if something else comes, we cannot say I will use only machine learning. We should be a problem solver. That's what the expectation from the machine learning engineers. In fact, I would go one level further up. Machine learning engineers or data scientists are expected to be magicians. You say something cannot be done, they look at you like, what, are you a machine learning engineer? They expect, okay, why is this not possible? Machine learning, they talk so many things fancy about it. There are limitations to, you are not a magician at the end of the day, right? So there will be accuracies. Whenever I report 75% accuracy, is this what your model can do? That is the question comes. Yeah, maybe somebody else can come up with another 5%, but can somebody be 100% accurate? Then it's like we have all the powers to predict the future. So yeah, the industry expects magic from machine learning engineers. Well, let's not get that, but we have to be more of problem solvers. I would say I am here to solve a problem. Yes, most of the problems are predictive problems. There are limitations to whenever I give a number, I don't give a number, I give a distribution. That's a probability. So the expected rate of tomorrow's expected number of COVID cases will be, when I say X, and I also attach a probability. The probability that tomorrow's the number of COVID cases will be X is 50% or 60%. So and that is how we can give predictions. We cannot be magicians at the end of the day. So that is my take. In the industry, many people expect machine learning engineers or magicians. Uh, but yeah, we have to be a problem solver. I would put it that way.
Thank you so much, sir. Thank you so much for this wonderful podcast. I think because like on my journey to be an right professional, I just started this podcast, and I think hopefully I reach out to a lot of people. Whether I reach out to or whether I don't reach out to, I think probably I'm just satisfied that I'm learning from a lot of people like you and the professionals like you and the engineers like you. And thank you so much for this podcast, sir.
Very good. Thanks for the opportunity. And this is something what you said is more or less everybody should be part of community nowadays. Either by doing podcasts or workshops or webinars, you should be visible. The visibility factor comes in. You can contribute to open source code. You can contribute to GitHub repositories. I would advise everybody should come out and showcase their interest, capabilities, and that they are approachable. That is important in today's world. One side it is professional profiling, another side it is social profiling, and being part of a community rather than being as an island isolated person. That is you are doing a good job there. I am also part of communities. I do webinars. I'm part of an open source community called Devopedia. We do a lot of things there. So it's nice way to be engaged with the community. You don't know what you will strike at what point in time. You may find a VC to fund your project. You may end up in a company in a good position, or you may end up knowing something which you never knew before. So build a social profile along with the professional profile. And I'm glad that you are doing your part by conducting webinars or basically not conducting, coordinating webinars or doing this podcast. You're doing a great job. Good luck. Anything else? Please let me know. I can be reached.
Thank you so much, sir. Thank you so much.